In this video, I will be showing you how to work out exercise 17.39, which reads: a copper pot with a mass of 0.5 kilograms contains 0.17 kilograms of water, and both are at temperature of 20 degrees Celsius. A 0.25 kilogram block of iron at 85 degrees Celsius is dropped into the pot. Part A reads: find the final temperature of the system assuming no heat loss to the surroundings. So we're gonna go down here where I started with my knowns, and we know that the total flow of heat is 0, so that's what I have. QT equals 0 right there. And then we use the specific heat equation for each of the materials we have listed in order to find the final answer. So right here I have copper, and we use the specific heat equation. Q equals M times C times T. So we plug in our knowns, and we get we get 195 joules divided by kilograms times Kelvin times T2 minus 3900 joules for copper. Move over to water, same equation. We plug in our knowns, and we get 712.3 joules divided by kilograms times Kelvin times T2 minus 14,246 joules. Then we move on to the iron block, same equation. Plug in our knowns, which gets us 117.5 joules divided by kilograms times Kelvin times T2 minus 9,988 joules. From there, we are able to go back to the first equation I showed with the zero heat flow, which is QT equals 0. And from there, we can input the change of heat in copper, water, and iron to equal to 0, and then we plug in the numbers that we got from the previous problems we just worked out. So we got the Q of copper, Q of water, Q of iron equal to 0. So let me simplify that to 1025 times T2 minus 2.814 times 10 to the 4th power joules equals 0. And from there, we can simplify the equation to solve for T2, which would be T2 equals 2.814 times 10 to the 4th joule divided by 1025 joules divided by kilograms times Kelvin, which is going to get us the 27.5 degrees Celsius, which is the answer.